Good day. We are carrying on with the gases sample questions. We did Charles' law and Boyle's law in the previous examples. So now we're going to move to the combined law. It's the same basic idea. Come on. So we're using P1 V1 over T1 equals P2 V2 over T2. And the question is, how do we know that? Well, we're given a volume here. We're given a pressure and a temperature. Then we see our volumes changed, our temperature changed, and we're after another pressure. So we have three variables at play that are changing. So we write down all of the knowns, the P1, V1, T1, the V2, and the T2. We don't know the P2. So we'd look at this, we would circle our P2 here. We know we're going to multiply what's adjacent, P1, V1, and we're going to multiply by the T2. Those things are all adjacent to the P2. We're going to divide by the T1 and we're going to divide by the V2 because they're right with the pressure. So simple algebra rearranging. So we write out that equation, get in that habit. Once we do that, the question's easy. Boom, 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 boom. We just substitute in the numbers. Now, some of you have those nice graphing calculators and you like to use brackets, that's fine. But if I'm doing this on my TI-32 solar powered calculator with pivoting head, I'm going to go boom times boom times boom, then divide by 40 liters, and then divide by 273. If I do that, then I don't need to use all these crazy brackets. But I do put the brackets in to make the units all tidy. So what I see is my volume has gone way down. My temperature's gone up a little bit. If I'm shrinking the volume, that means my pressure has to have gone up. So I'm expecting to get a number bigger than 85 kilopascals. And when I do this, it's gone up, way up to 551 kilopascals. So you always want to see, does your answer make sense? Now this question is basically the same idea. It happens to be another final pressure question. So I'm using the same formula. Got all these numbers that I've just pulled out of the equation. I remembered to make everything that was in Celsius. I've got to put it in Kelvin. Cannot use Celsius temperature with these formulas. And what I see is my volume's gone down and my temperature has gone down. And so I say, oh, what's at play here? So I plug in all these numbers. And seeing as this was in atmospheres already, I'm just going to let my answer come out in atmospheres. No reason to do a shift, just the way I had kilopascals here. By doing all these things with units, I can see that that I had milliliters there. And by the way, that should have said milliliters there. That's a little typo there. Fix that up. And you'll get the 2.31 atmospheres. Now we're finishing off with the ideal gas law. And that's our PV equals nRT. And we use this when we don't have changing conditions and when we see words like moles or mass, head straight to ideal gas law. So here we're given a question that says, what's the mass of 4 liters? So here we have volume and we have RTP. Now we could short circuit it and reuse what we remember about molar volume, but we're going to do it the long way. So to get mass, first we have to get moles, remembering all that stuff from Chemistry 11. So N equals PV divided by RT. Hopefully that makes sense. Here's N. PV is on the opposite side. RT is right next to it. So the RT when they cross the equal sign, have to jump to the bottom. My pressure is 1 atmosphere at RTP. My volume was 4 liters. Since I'm using atmospheres, I use the 0.0821. I didn't put in all the units for R. And I know room temperature pressure is 298 Kelvin. When I plug those numbers in, I get 0.163 moles. Now chlorine is diatomic, Cl2, so its molar mass is 70.90 grams per mole. So I take that, multiply by the 70.90, and I get 11.6 grams. The next question is going to take us in the reverse direction. Instead of finding mass, we're going to be going from mass to figuring out volume. So our first thing is to get the moles. 100 grams, we divide by molar mass. Now we have the 2.27 moles. We're not at STP or RTP, so at this point we're going to use the ideal gas law. When we rearrange our equation with the ideal gas law, we get V equals nRT divided by P. I want the volume by itself, nRT is the other side. P has top to the bottom when we're doing this. So I've written out all these numbers pulled straight from the question. 0.5, V was the unknown. 2.27 moles, I just calculated. I'm using 0.0821 because I was given the pressure in atmospheres, and that's for atmospheres. And 100 degrees is 373 Kelvin. Then I write this carefully, and I go boom times boom times boom divided by bam. And I get 139 liters. So there you have the completion of 8 examples. You're going to have a worksheet that look at these kind of questions, ask you to do a bit of thinking, but refer to these notes, show your work properly, identifying the unknowns that you're substituting and the knowns, and make sure you put the formula and show the substitution, and everything should be good.